Hello from Chem Help ASAP. We're going to talk about high oxidation state functional groups. And of course, we're referring to the oxidation state of carbon. And all these functional groups are going to have 4 bonds from a more electronegative atom to carbon. That's going to be our theme. Now, as it turns out, once we get to this high oxidation state, all 4 of our bonds to carbon are electronegative atoms, which means we don't have a carbon-carbon bond. So we won't see these functional groups in our molecules very often, but sometimes we will, and it's worthwhile knowing just to complete our series. So the first molecule I want to talk about is this one. This is carbon dioxide. Obviously an important molecule. And notice that carbon has 4 bonds to a more electronegative atom. Another molecule that you've probably heard of before is this one. It has biological relevance. This is urea, part of how your body processes nitrogen, and it stores nitrogen to be excreted in urine. So urea is another. Ureas all have that central carbon, which has 4 bonds to more electronegative atoms, 2 bonds to oxygen, 2 different nitrogens. Then I'm going to show a series of compounds at the bottom. Turns out when CO2 interacts with water, it forms something called carbonic acid. Now CO2 and water mix in the ocean, so you form carbonic acid in the water, and carbonic acid can be deprotonated to form the bicarbonate anion. And furthermore, it's possible to deprotonate this again and form the carbonate dianion. And this is part of the buffering system of seawater, and this plays a big role in the carbon cycle of the globe. How water is buffered, the ocean water is buffered, and how oceans can absorb CO2 and release CO2. So high oxidation state carbon functional groups are extremely important. From a synthetic organic chemistry standpoint, we won't see them very much, but they're absolutely out there, and they play a big role in things like biology as well as the environment.